One of the best things about Java is that it's a statically typed language. This helps us know what different objects are at compile time. Well, there are some limitations to a statically typed language, and that's that we always have to specify the type. Well, I'm going to show you a trick for dealing with situations where you know better than the compiler what an object is. Let me show you. So let's say I have a variable, and it's going to be of object type. So since everything inherits from object, this should be fine if I want to do something like this. Now, this is fine, but you can see when I actually try to use A, I only have the methods available to me that are in the object class. This means that if I try to do something like this, I'm going to get a problem. As you can see, the compiler is complaining, saying you can't set something that's supposed to point to a myClass object and then just point it to a generic object. I can't guarantee that functionality is there. But we happen to know for sure that, hey, that's actually pointing to a myClass object. Well, with typecasting, we can fix this. All you need to do is put the actual class you want to use in parentheses in front of the assignment. It's kind of like photobombing at that particular moment. As you can see, there are no complaints. You do have to be careful with this, though, because now we are manually deciding what an object is at runtime. If, for instance, this was not actually a myClass object, I would get errors later. But for most of the time, when you actually know what something is, you can cast it to exactly what you want it to be. You can also do this with primitives. Let's say I want to have an integer that's a random number. Well, there's this method called mathRandom that will give me a number between 0 and 1. Well, if that's between 0 and 1, and I want a random number from, let's say, the beginning to the end of a list, I can just multiply that by the list size, and there I have it. Now, again, the problem that I have here is that this side of the equation is a double. This side, I'm asking for an int. I would normally have to take a bunch of methods, convert it, and ask for different data types to change that double into an int. But I could also just cast it to an int. Now you have to be careful with this because certain casts, again, are not going to work. You can't just cast a char into a double and expect to have a value that makes sense. But oftentimes, for simple things like converting floating point into integers, you can use this technique and make your code much more readable.